Welcome to Qt Widgets and More. In today's episode, I'm gonna make a fool out of myself. I'm gonna show you how much trouble I had implementing something as trivial as operator less than. But fortunately, there was a lesson or two to be learned in the process. So how difficult can it be to implement an operator less than, you ask? Yeah, sure. You just take the most important of your instance variable and compare that with its operator less than to that of the other instance of your class or whatever you're comparing. Well, let me show you the code that I had. It looks like this. Actually, there's two changes to it. First of all, my class wasn't called foo. And second of all, I formatted the code so that it was more easy to read. Clang format definitely did not help with this code. But what it reads here is that if x is less than the other's x, then of course the whole class is less than. Otherwise, if x is equal to the others, then it's if y is less than. Otherwise, if they are the same too, then it's set that matters. And just imagine this code continuing on with a few more instance variables. It wouldn't be pretty. As always, I prepared an example for you and it's available on GitHub. Check the links below. And in this example here, I have 9 steps. And if we just start looking at step number 1 here, you can see here's the implementation of this foo with the operator less than. There's even a bunch of test cases below so that I actually validate that my operator less than does the right thing. What you see here is how Clang format decided to format it, and you can read, this was what was on the screen just a minute ago. You can read, or you can see that it's much harder to read now. I'm not bashing Clang format, I'm just bashing my own implementation of operator less than. Basically what I test here is if x is less than the other, that is fine. Otherwise, if they're the same and y is less than the other, then that is fine. Otherwise, if they are the same and set or c is less than, then it's fine, or then left hand side is less than right hand side. And there is a few changes already in this example compared to what you saw on the screen. Well, there's one change, namely that it's a friend here, and the reason for that, there's a link below telling you about the whole concept of this hidden friends and whatnot. But the very short story is that if I had my operator less than just taking a const foo other, then depending on the semantics of C++, this other would go into a game of implicit conversion if I needed to, while the left-hand side wouldn't. So that could give us some confusions. Let's look at a much better implementation of this though. We have that in step 2 here. Here we can say that if they are not the same, then let x decide. So if left-hand side's x is not the same as right-hand side, then we already know that we can just look at x to decide. Otherwise, that means that they are the same x, and now it's y that I check. Otherwise, I check set. And had there been more instance variables I wanted to check, then I would just have continued on. What got me started with all of this? Well, my operator less than actually did work. So I got started from a coworker that wrote on our internal chat, hey, you should actually all go and check up on your operator less than, because a nice way of doing this code here is to use std::tie. That's what you see right here. std::tie, it's operator less than. So std::tie, create me a tuple, and it's less than. Simply take each of the variable in the tuple and compare them. So if x is less than, or left-hand side's x is less than right-hand side's x, then it is okay, or it will return true. Otherwise, if they are the same, then it compares y, and if they are the same, compares z. I guess that we can all agree this reads out much easier on the eye than this, and it's much easier to write than that. So I grabbed on in my own source code to search for other operator less than, hopefully to rewrite them to this much more beautiful std::tie. And I found a class called partial date. Partial date is inspired by QDate, And partial date, the partial part of it is that it's really just a month. So a year and a month, no day. Partial date, as I said, was inspired by QDate in that it has this optional built in. A QDate can be a real date like July 11th, 1971. Wonder whose birthday that is, and thank you for all the birthday wishes, by the way. Or it can be a null. So read a date, you can return a QDate, parenthesis open, parenthesis close, that doesn't have any value in it. Partial date, exactly the same thing. It turned out to be not entirely trivial to rewrite using std::tie, and let me show you why. So here, my foo is the partial date thing. It has a value and it has isValid. So the value is just an integer for is here. And isValid is either true or false. And if it's true, then it is then it's the value that counts. So it's an optional value in here. My operator less than looked like this. It said that if the left-hand side was not valid, meaning that it's the null object, then return whether the right-hand side was the null object. So two null objects comparing, if they would say, no, they are not less than each other, null object and anything else, yes, the null object is less than anything else. That way, if I sort them, I would always have the null object first. The second test here is that if my left-hand side wasn't a null object, it was a valid object, and my right-hand side was a null object, then it was not less than, because the right-hand side, the null object should be the first in my sorting. Otherwise, I know that both of them are null and are not null, and therefore I can just compare the dates or the integer in this example here. So I tried rewriting that with std::tie. It looked like this. Stud::tie m, left-hand side m is valid, left-hand side m value, and same for right-hand side. I tried that out, and occasionally my application produced wrong results in here. And the reason for that is that if they are the same, then it will continue on. That's what std::tie or the tuple operator less than does. It continues on to the next element if they are the same, which was not what I wanted. If they were not the same, then, or if they were the same, rather, if the first element was null, then it didn't ever carry on. It just looked at the isValid for the other one. But here, if both of them is not valid, meaning they are the same, then we continue on to the next one. Therefore, I needed this explicit, making sure that my value down here was 0. And it worked for this case here, because the only way I can construct my partial date or my foo object up here is by two constructors, one giving the value and setting it to true, or one not giving anything and setting it to, or using the default false. But in general, had I had a way of doing something else, I would actually not have been able to use the stud::tie. And as so often before, I lied to you. I'm sorry. My partial date did not have an property or an instance variable called isValid. It had one called isNull, the opposite of isValid. And that actually gave me a lot of extra gray hair trying to fit that in with std::tie. You can see my class foo again here, this time with isNull, that is the opposite of isValid. It's initialized to false when I provide an integer, otherwise it'll take the initialization down here, which is true. Step number 1 inside of this, or version number 1 inside this step here, you can see what it looked like originally, and that one works out. You can actually run the code and you can see the comparing down here that they actually works out. Step number 2 is what I tried based on my previous attempt with std::tie, but what you'll see here is that I just take the isNull and value here, and that gives me the wrong result actually, which you can again see if you run the code. Because if I have something that is null, that's true, that's my left-hand side, guess looks like this for you. My left-hand side is null, and I compare that to a valid one that's false, so true is less than false, which means that my isNull will sort at the very end of all the valid versions, which of course is not what I want. Okay, how do I do this? Well, how about step number 3? And you can see here a red dot indicating, yeah, this doesn't even compile. That's not how std_tie works. So I cannot do like this. std_tie simply just makes it creates a tuple with references to each of the elements in here. Okay. Step number 4. This works. Let me just go and puke a bit on this code here. Right hand side is null, left hand side is null, left hand side value. Yeah, I just flopped them over so that it would work. This will never ever be readable. And then of course I could create the tuples myself, which I did here. Now I created a tuple and this compiles too. Of course, what's the difference between std_tie and std_tuple? Well, std_tie create your tuple, but a tuple where each of the elements are just references. Here they are actually copies. So this shouldn't be the general case. It should be std_tie, and then this should be, well, whenever you can't use std_tie. We just spent a bit of time looking at std_tie together with operator less than. We can now spend the next 3 minutes looking at operator greater than and std_tie. Very boring. Or we can go backward in time to 2020, namely C++20, and look at how does the spaceship operator do this for us. So in case you haven't followed what's new in C++20, the spaceship operator is this operator less than, equal to, greater than, and you can see it looks a bit like a spaceship whenever you're not using the font that I'm using in here. But anyway, what it does is that it actually lets you implement less than and greater than and equal to and less than equal to and greater than equal to, all of these in one go, because if you try and implement them, you notice they do the same thing again and again. And let's see what it looks like. Let's start with version 1 here. So I tried implementing it, and again I had this this ordering issue that the isNull should be ordered as a very the objects that are invalid or isNull should be ordered at the start of the ordering sequence. So I had to make them into a tuple and then negate here. And I also had the problem that if I had 2 that both were null, then it would carry on. That's what your operator spaceship here does for you. Then it would carry on to the next element, and that's not what I wanted. Well, in any case, I needed to make sure that the follow-up was initialized as it was down here. So maybe going back and making it less magic, just implement something that looks like this. If the left-hand side is not null and the right-hand side is not null, meaning both of them are valid partial dates, or both of them are valid, just the integer down here, objects, then I will go and compare those objects here. And had there been a bunch of them, I would do my regular step-by-step comparing of them. Otherwise, if one of them is, then I'll go and do this here. And actually this is the third recording of this part of the segment, because I realized I actually had them wrong. So good that I had unit tests below. You see, well, they are not really unit tests, but still tests that could print out. Because what I want here is to do the spaceship operator with the not is null. So I compare valid and valid, so that again, my null objects sort first in a sequence of my elements. It is amazing what I can put you, my dear viewer, through. This is Qt widgets and more, and absolutely nothing what I've been talking about today is about Qt, but hopefully it was still useful for you. But let's finish up looking a bit at how do you do this with Qt, namely more specifically QStrings. This time we don't have foos anymore, we have employees. Employees are somebody with a name and an age, a very simplistic view of the world, but nevertheless, my operator less than simply compares first the name and then the age. That looks good, right? But it has 2 problems. Problem number 1, what do I do if I want to sort them by age and then by name? Let's not go why I want to do that, but what would I do? Well, I could set let's not go and set flags anywhere, that's just wrong. There's a better solution. The problem number 2 is how do I actually sort them? And let me just run the code here. Step number 8 is what we have right up here. And you can see that Maria is twice, and I therefore sort it by H. That looks good. Then we have Martina and Mario. But Mario is, you would expect it to be before Martina, because after all, I is before T. I cannot show you that. Well, this T here is before this I here, but that's not how it sorts. It sorts by looking at letter by letter. That's what your QString operator less than does. It looks letter by letter and compares the Unicode value. And the Unicode value of this A here with the on top of it is much later in the sorting than the A's. Therefore, Martina already wins the race on her second letter in Martina. So how do we solve this? Well, there's two ways of solving this. So two things that we need to solve. So first of all, we need to solve the sorting, and we do that by using local aware compare. So by looking at local aware or calling local aware compare on the string with another string, it will actually return -1, 0, and +1. So the sorting according to how you interpret it. And if we run this example, you can see step 9 here, sort by name. Mario is before Martina, even though the Unicode version there would be later. And then to the second part of the sorting in here, instead of implementing an operator less than using that, we should implement a number of static methods by name, by age, by name and age. And as you can see here, they all returns a Boolean whether left-hand side is less than right-hand side. And now in the implementation, what I can do is calling sort. I can give it a third parameter, namely this by name, and just let's all meditate here for a second and enjoy how beautiful this sorting line is. Sort the employees begin and employees end, and of course that could have been done much better with that thingy in C++20, I can't remember right now. But the beauty of this is the employee : by name. So sort by name, sort by name and age, sort by name, and sort by age. Read much better to the eye this way, and I also have now the option of actually sorting by the different parameters. And it's of course called ranges v3, the facility of not doing the begin and .end, but that might be for another episode of Qt Widgets and more. Sometimes life is a bit of surprise, isn't it? I mean, how difficult can it be to implement operator less than? I'm sure you said that up front, and hopefully you've seen that there is more to it than what the eye meet. But at least my code now looks much more clean with proper operator less than throughout the whole code base, which hopefully will help me not introduce bugs in that area, at least in the future. I hope you enjoyed this episode, and do stay tuned for the next episode where I will interview our own Giuseppe D'Angelo on what is this QsConst? Why do I need it? When do I need it? That's next time in Qt Widgets and more. Until then, have a great time. Thank you for watching yet another episode of Qt Widgets and more, but I have one more thing to tell you. On June 13th to 15th, KDAP is going to host a developer conference in Berlin, and I'll be there to collect all the beers that you owe me after all these fancy episodes. No, seriously, there's going to be lots of interesting topics, both on QML, which you might or might not be interested in, but at least you can dip your toes in what is that about and see if that makes sense for you, even on desktop. And there's going to be some very strong C++ presentations and much more. Go and check out the program, and well, I hope to see you there.